Polygons are shapes with straight sides. So take a look at these shapes down here. Which two of these are polygons? Nicely done. So these two shapes are polygons because their sides are all straight. This shape down here is not a polygon because it's curved. To be a polygon, a shape must also be closed, meaning it has a separate inside and outside. Here's a shape with straight sides, but it's not closed, so it's not a polygon. Also, a polygon's sides never touch. In this shape, this side touches this side, so it's not a polygon. Now, polygons are given specific names based on how many sides they have. So to get started, how many sides does this polygon have? Exactly. This polygon has 1, 2, 3, 4, 5, 6, 7 sides. Now, any polygon with exactly 3 sides is known as a triangle. So which of these polygons here are triangles? Right, these two polygons are triangles and each of them has exactly 3 sides. A polygon with exactly 4 sides is called a quadrilateral. That's a pretty long word, but the most important part to remember is quad, which is a prefix that means 4. Okay, so which of these polygons here are quadrilaterals? Excellent, you really got the hang of this. Pentagons are polygons with exactly 5 sides. So which of these are pentagons? Nicely done. Okay, last one for now. Polygons with 6 sides are called hexagons. So which of these polygons are hexagons? Great, so these are hexagons. So just to review, here are some polygons you've seen already, and here are their names. Here are a few more with even more sides. Polygons with 7 sides are called heptagons, 8 sides are octagons, 9 sides are nonagons, and 10 sides are decagons. So a lot of names. Don't worry too much about memorizing all of these right now. You'll remember their names the more you see them. For now, take a look at this stop sign over here. Do you remember what kind of polygon this is? If not, feel free to ask for a hint. Right, this has 8 sides, so it's an octagon. Finally, let's talk about how to properly name specific polygons. Suppose you're talking about this triangle over here, whose vertices, or corners, are the points D, E, and F. Well, triangles are actually named after their vertices, so you can call this triangle DEF with this triangle symbol over here. You could also call this triangle EDF, and you could even call it EFD. As long as these 3 points are the 3 vertices, then this is a correct name for our triangle. Now here's another triangle, and let's label some points. Which of these names down here are correct names for this triangle? Excellent! GAP and APG are both correct names. Triangle BPG is this blue triangle over here, and triangle CPA is the orange one over here. Now in general, polygons are named after their vertices, or corners, in the proper order. So for example, here's a quadrilateral and we've labeled its 4 vertices. One name for this polygon is R, then A, then C, and then E. If you go from R to A to C to E and then back to R where you started, you go around the quadrilateral. So this is a correct name. What about AREC? Well, if we start at A, go to R, then to E, and then to C, and then back to A where we started, we again have our quadrilateral. So this is another name for our polygon. But what about EACR? Well, let's start at E and go to A, and then to C, and then to R, and finally back to E where we started. So this is not our quadrilateral. It's the same 4 vertices, but in the wrong order. So EACR is not a correct name for this quadrilateral. As your final challenge, take a look at this pentagon here, with vertices A, B, C, D, and E. Which of these are correct names for this pentagon? Look carefully at the order of the letters in each of these answers. In this lesson, we'll introduce congruence and what it means when we say that line segments, angles, and shapes are congruent. Let's start off with line segments. Line segments are congruent if they have the same length. So take a look at these four line segments over here. Which two of these are congruent to each other? Right, these two line segments are congruent because they have the same length. Similarly, angles are congruent to other angles if they have the same measure. So take a look at these four angles here. Which two of these are congruent? And if you'd like to review how to measure angles instead, click down here to learn all about degrees. Precisely, these two angles have the same measure, so they're congruent to each other. It looks like they both measure about 120 degrees. Finally, let's talk about congruent shapes. Two shapes are congruent if you can turn one of them into the other by moving, rotating, or flipping it. For example, take a look at these four shapes here. Which two of these would you say are congruent? Nicely done. Yes, these two shapes are congruent. According to this definition, two shapes are congruent if you can turn one of them into the other by moving, rotating, or flipping it. Now if we move this blue shape so it's on top of this purple shape, we see that they are indeed the same shape, so they're congruent to each other. So this was an example of moving shapes to show that they're congruent. Next, let's involve rotation as well. Take a look at these four shapes. Which of these are congruent to each other? In this case, which shapes can you turn into one another by moving and rotating them? Exactly, these two shapes are congruent. To show this, we can move this purple shape so it's on top of the green one, and then we can also rotate it so they're aligned. Since we've turned one shape into the other by moving and rotating it, these two shapes are congruent. Now what about flipping a shape? Well, take a look at these four shapes. Which two of these would you say are congruent? Precisely, these two shapes are congruent. To see this, let's first move the yellow shape so it's on top of the orange shape. They don't quite align, so we'll have to do a little more work to show that they're congruent. We could rotate the yellow shape, but no matter how much or how little we rotate it, we still can't turn it into the orange shape. So for this example, these two shapes are congruent because you can turn one into the other by moving it, rotating it, and flipping it like this. As a side note, when showing two shapes are congruent, you can use any of these strategies, moving, rotating, and flipping, and you can use them in any order you want. So try another example. Of these four triangles, which two are congruent? Right, so these two triangles are congruent. You can see that by moving them and then flipping one of them. Let's finish this lesson with some notation. So here are two congruent line segments, AB and CD, and they're congruent because they have the same length. Now there's a quick way to write down that two things are congruent, using this symbol here. It looks like an equal sign with a squiggly line on top, and you can read it aloud as is congruent to. So this statement here says that line segment AB is congruent to line segment CD. So try another example. Here are the two angles from before that you said are congruent. So they have the same measure. The measure of angle ABC equals the measure of angle PQR. So then which of these statements down here is also true? Don't worry, this is not a trick question. Right, so saying these angles have the same measure is the same as saying they're congruent. Angle ABC is congruent to angle PQR. Finally, let's look at polygons, like this triangle ABC. Let's draw a congruent triangle, which we'll call XYZ. So here's how we can write that these triangles are congruent. Triangle ABC is congruent to triangle XYZ. Now the precise order of the letters here is important. This means that point X corresponds to point A. If you align these triangles, A and X both represent the same vertex. Similarly, Y corresponds to B, and Z corresponds to C. So next, here's triangle DEF, and suppose I tell you that triangle DEF is congruent to triangle PQR over here, but I don't actually label the vertices. Try using the order of the letters from this statement to figure out which vertex is which, and then identify which of this triangle's sides is QR. Excellent! So to get started here, you can label these three vertices. According to this statement, D should correspond to P. So if this is D, then this vertex is P. And we can see that these 2 points correspond by rotating this triangle and then flipping it over. So yes, this must be P. And if this is vertex E, then this must be Q. And finally, if this is F, then this is R. So which side is line segment QR? That's this side over here. You might have noticed that QR corresponds to this side over here, EF. And you can actually see that using this expression. Remember, the order of these points matches the order of these points. So just from this expression, you can see that line segment EF must be congruent to QR because they have matching places in these names. Okay, last question. Here are two congruent quadrilaterals. So then which of these statements over here are correct? Pay very careful attention to the order of the points in each of these and make sure the orders match.